Good day and welcome. I'm Mr. Simons. This lesson we're looking at ungrouped data, mean and standard deviation, and how we use it together. Very important, definite exam question for grade 12 in South Africa. So, standard deviation, we determine using the volume formula, square root of variance or square root sum of x minus the mean squared over n, right, or via calculator. So you have a Casio FX 82 ES Plus. It's most learners in South Africa. Your calculator, you're going to press mode. On the screen, it will show 1, 2, etc. You select 2 for stat. Then after that, you select 1, which shows 1 variance. Right? Then we're going to enter our data points. So data points 1 equal, 5 equal, etc. Once we've entered all the data points, we're going to press AC, then press Shift and then select 1 on the calculator. Under your values, then 5 for variance, and some calculators would have 4. So that I select 3 for standard deviation, push equal, and I get standard deviation. So you can pause and take the steps down and do them over and over on your calculator. For sharp, press mode, 0 for standard deviation, enter the data points, right, followed by M plus, so push data value M plus, data value M plus, and then we're going to press recall 6 to get standard deviation. That's on the EL 531 WH, sharp EL W535 HT right view, mode 1. Select 0 for standard deviation, enter data values, press change. When all values are entered, now instead of saying recall 6, we're going to press alpha 6. To clear the calculator, we just then press mode 0. Then we can start all over again. So very important you know this procedure. I'm going to show you manually how we work this out for 2 marks in exam. Right, and you'll see it's way too much work to do for 2 marks, therefore we use a calculator, but I still believe you need to see it from all directions, right? So, consider the following set of data values: 45, 52, 85, 92, 92, 100, 110, 120, 125, 136. Alright, they have listed them. As you can see, I have 10 values. So, n equal 10. X, there's all my values. If I add them all together, the sum of all that values is 957. Right, to get my mean, it's going to be 957 divided by the 10 values, which gives me 95.7. Right, now to work out standard deviation, I first need to know what's x minus standard deviation. So x 45 minus 95.7 minus 50.7. 52 minus 95.7 minus 43.7. 85 minus 95.7 minus 10.7. 92 minus 95.7 minus 3.7. Subtract that 2 minus 3.7. 100 minus 95.7, 4.3. If I continue subtracting, 14.3, 24.3, 29.3, 40.3. Right? Then I need the square of all those values. So minus 50.7 squared gives me 2570.49. Minus 43.7 squared equal 1909.69. Minus 10.7 squared, 114.49. If we continue in that vein, there's all the values I get. Right? So, the sum of all of that, now I'm going to add all these values. So, if I add all 10 values, I get 7,938.10. So, you can pause here, look at the screen, you can write it out if you want to, you can double check. So, for my mean, you saw how I calculated the mean. For standard deviation, square root of my variance. So x minus x squared, 7, 9, 38, 10, or 18, 10, apologies, divided by n, which is 10 values. It gives me square root of 791,81. So my variance, 791,81. Square root of that gives me a standard deviation of 28,14. So that's a very long procedure for 2 marks, sometimes only 1 mark. That is why we prefer doing it on the calculator. Alright, let's go to it. So determine how many values fall within 1 standard deviation of the mean. So 1 standard deviation of the mean, mean minus standard deviation, mean plus standard deviation. I first get an interval. So my mean was 95.7, standard deviation 28,14. There again, 95,7 plus 28,14 gives me 67,56, 123,84. So how many fall within? How many fall within that interval? So values bigger than 67,56 and smaller than 123,84. So if I look there, 45 smaller, 52 smaller, 85 bigger than 67,56. So I start by 85. Smaller than 123, 125 is bigger, so we end by 120. So if I list 85, 92, 92, 100, 110, 120, gives me 2, 4, 6 values. Out of the 10 falls within 1 standard deviation of the mean. Now mathematically, 1 standard deviation from the mean represents roughly, say, 67% or in this case 68% of the middlemost data. Right? So we use it to check. If we say 100 learners wrote a test, out of the 100, 68 out of the 100 should fall within 1 standard deviation of the mean, meaning their results must be within that. If it's not, then it means it's not a fair test, and therefore we then have to manipulate and change data. Right? Now we can also change the question, determine how many values fall within 2 standard deviation of the mean. So one of the 2 will always be tested in the exam paper, right? That's with discrete data or univariate data, or ungrouped data. Right? So when I say 2 standard deviations, mean minus 2 standard deviations, mean plus 2 standard deviations. So 95.7 minus 2 times 28,14, 95.7 plus 2 times 28,14. Now my interval starts by 39,42 up to 151,98. You can see 45 is bigger than 39,42 and 136 is smaller than 151,98. So therefore all 10 values fall within 2 standard deviations of the mean. So 10 out of the 10 values. Right? And 2 standard deviations from the mean represents 95% of the middlemost data. So again, if we want to verify 95 out of 100 learners that wrote a test, their marks must be in between 2 standard deviations of the mean. We can also change this question. Look, next problem. Determine how many values fall outside. You see the other 2 was inside, within. How many values fall outside 1 standard deviation of the mean? So the same thing I've done previously. My interval was 67,56 to 123,84. So smaller than 67,56 is 52 and 45. Bigger than 123,84 is 125 and 136. So therefore I have 1, 2, 3, 4 values out of the 10. So as I said, 1 standard deviation from the mean represents basically 68% of my middlemost data. Hope you enjoyed the lesson. Please like, share and subscribe. Right? God bless. Wish you nothing but the best. Bye.